In this video, we're going to do the classic Beer's Law experiment, or we're going to do it wirelessly with a Go Direct SpectraVis Plus spectrophotometer and an iPad, and we're going to connect the two with Bluetooth wireless technology. To do this, first thing we're going to do is launch the Spectral Analysis app. At the same time, I'm going to turn on the antenna on the SpectraVis by pushing the button on the side. A blue light will flash, indicating that the SpectraVis is transmitting. On the software, we'll tap on Connect the Spectrometer. Our spectrometer will transmit an ID number. We will tap on the Connect button next to the ID number. Once the spectrometer is connected, then we will tap on Done. Beer's Law is the study of the absorbance of a solution related to the concentration of a solution. So for that experiment, we will need the second choice here on the menu. With spectrometers, it's common to calibrate the spectrometer before you use it. The software will automatically enter the calibration mode. What we need to do is put a blank solution of solvent into the spectrometer. Solvent in this experiment will be water. The cuvettes have clear sides and they have fluted sides to hold them. We need to make sure to align the cuvette in the spectrometer so that the light through the spectrometer goes through the clear sides of the cuvette. The software will count down from 90 seconds. If you've been using the spectrometer for a period of time, you don't have to wait the whole time. You'll notice that by now we have the option to skip the rest of the countdown, which I'm going to choose to do. If you're starting with a cold spectrometer, you wouldn't want to do that. I'm going to tap on Finish Calibration, and the system is going to go through and calibrate all the wavelengths this spectrometer is capable of recording. Next step in this experiment is for the students to decide what wavelength to use to measure our absorbance, and so we need to put a sample of our solution in there. I'm going to take one of our solutions, and we're going to align it so that the light passes through the clear side of the cuvette and allow the system to measure the absorbance of the solution. So you'll see a graph pop up on the screen. Students need to realize that the best choice would be the wavelength of highest absorbance. The easiest way to select that is to tap on the graph. You can fine-tune it by either moving the flag until you get to the point you want, or you can tap in the box and type in the value that you want. For this experiment, 630 nanometers works very well. Notice that a small graph pops up there to remind us of the wavelength that we chose. I have one of my known solutions in the spectrometer already, so all I need to do is start collecting data. I'm going to wait until the absorbance value reaches a maximum value, and then once that is pretty stable, I'm going to tap on Keep. This is one of the known solutions, so I know the concentration of this sample. I will type that in to the concentration box. This one is 0.32 molar. Now I replace that sample with another known sample. Once again, making sure to align the light path. Allow the system to reach a maximum absorbance, so you can see that in the live meter right there. Once that is stable, I'll tap on Keep. Type in the concentration of that sample. Need to repeat this process a couple more times for the other known solutions. I've entered all the data for known samples, so at this point I'm done collecting data to plot on the graph, so I would tap on Stop. My goal of this experiment is to find the concentration of an unknown sample. So here's my unknown sample. I can put it in the spectrometer. This will read the absorbance. What I need to do is use the graph to determine the concentration. So to do that, I need to fit a line on the graph. To do that, I would tap on the Graph Options mode and then choose Apply Curve Fit. The relationship between absorbance and concentration is a linear one, so the linear fit is very appropriate. I'll tap on apply. At this point, it's up to you how you have your students determine the concentration of the unknown. One way to do it would be to take the regression statistics from this box. The absorbance value would be the one we are measuring here for the unknown sample. Plug that in for the y value. Solve the regression equation for the x value, which would be the concentration of that sample. Another way to do it is to use the software to calculate the concentration for you automatically. If I tap on the graph options button again, I have a choice here for interpolate. I'll turn that on, tap on the graph. I get a line that indicates the concentration and absorbance at that point on the graph. In this case, I would like to move the line so that the absorbance reads what the absorbance of the unknown solution is. To do that, I take the flag here and just slide my finger until the absorbance reading is the same as that of the unknown. The concentration of the unknown then, in this case, would be close to 0.199 molar. This is how you do a basic Beer's law experiment. Beer's law is a very common process that is used in many experiments in chemistry, in our advanced chemistry book and our AP chemistry book, as well as our first year chemistry book. If you have any questions about this experiment or anything else in chemistry, please don't hesitate to write to us at chemistry@vernier.com.